know if you can see my remix, if you can see the code up right now.
Yep,
All right, cool. Then we are good to go. You can go ahead and start the recording.
it was started 10 seconds ago.
It sounds good. All right, well, welcome everybody to part two of creating your own token smart contract. So the plan right here is I'm going to quickly go over a recap of what we did in part one, just to get people up to speed that weren't there earlier for the first one, and then just as a refresher as well for those of you that were a part of part one or watched it on YouTube. And then we'll go into finishing up this smart contract at a very foundational level. Obviously, when you're coding a token, there's a lot of complex things that you might want to code in, like airdrops or transaction fees, those kind of things that we won't go into right now. But by the end of this hour here, we'll have a completed token smart contract that will really give you the basis to expand upon to add those other features like transaction fees or staking or whatever, with this as the base. Like this is the token and all you'd need for it. If all you want to do is deploy a bare bones token. So yeah, what we did last time is we had a bit of an introduction to Remix, which is just a way to code smart contracts in the browser. So you don't have to install anything or download your local blockchain to run on your computer. So it's very simple and easy to work with. And then we created a .sol file, which stands for Solidity. So that's the extension of the Solidity files for smart contracts. And we called it Giga Gains, just kind of a silly name for a token. And so within this file right here, the first line of code, and this is just kind of getting into the recap right now. The first line of code is specifying the license on this, which is almost always going to be unlicensed or MIT licensed, which just means it's open source, like anybody can use this code. Because everything on the blockchain is really available for anyone to see. And so it's rare that you actually try to copyright your code. It doesn't really make sense to anyway. And that's why forks are a thing. And then the second line right here, this is defining the version of Solidity to use. Because just like any application or video game that you have on your computer, programming languages also have a version because they have fixes for things. Because like in Solidity 1, or I guess version point 1, there was a ton of different errors and stuff and things that cause vulnerabilities. So they have to fix that over time, just like you would with an application. And so this is defining which version of the programming language to use. And then the way that you define a smart contract at a very basic level is with this line of code right here. You are declaring, I am making a new contract, and it is called Giga Gains. And then these squiggly brackets that you see right here, they encapsulate everything within the contract. So I have this starting squiggly brace. And then if I scroll down to the end of the contract code that we made in part one, I have this ending squiggly brace. And so that defines everything within here is the code for the smart contract. And then, just like with any other programming language in Solidity, you have variable types. So we have integers, which are numbers, and then we have strings, which are words. So in this case, we have a unsigned integer. Unsigned means that it can't be negative, as in you don't have a plus or a minus sign. And then the 256 just defines how big of a number it can get to. So this defines how much storage space on the blockchain is available for this variable, and we call this the total supply. So this is a number that represents the total token supply for the GigaGains token. And then private is saying that this variable cannot be viewed by anybody. It is internal to the smart contract. So when you have a public, if I made this public instead of private, you would actually be able to read this value on an explorer like the Binance like, Scan Explorer or the Ether Explorer, that kind of thing. And then we got a string, which is the name of the contract, like Giga Gains, and then the symbol. So that could be like CRNL for the Cardinal token here at Cardinal House, that kind of thing. And then there's another type in Solidity called address. And this is really important because the blockchain runs on addresses. Everybody has an address, and that's where their tokens are stored. That's what they use to run their operations on the blockchain. And so that's a type in itself in smart contracts, the address. And so in this case, this variable is it stores who the owner is of the smart contract, who deployed it, who gets to run those special operations like minting tokens, for example. And then right here we have a mapping. So this maps an address to a number. and this is the balances mapping. So it's saying for a given address, how many tokens do they have? So you can see how that mapping works. Like this person has this many tokens, and another address, they have this many tokens, and that's all stored in this single variable right here. And then we have a constructor, which is the function that is run the first time you deploy the contract. So this function is only run once, and it's run right away when this entire smart contract is put on the blockchain. And we have parameters here that we give when we are deploying the smart contract. So if I go to the deploy tab on Remix, which is this bottom option right here in the left toolbar, and I look at the deploy option right here, you can see that I have to specify these parameters. So these three parameters that you see right here, we have the name, the symbol, and the total supply. Those map directly to these parameters that we see right here. We have the name, the symbol, and the total supply. So it's a string for the name because it's a word, same with the symbol. And then the total supply is a number. So that's why you have the unsigned integer with the 256 for the size. And so then we just set those values in the smart contract. So now these values, they have something now. These variables have values because we set them here in the constructor. And then we mint tokens. So we actually create the tokens in the constructor because right when the contract is deployed, we want to make those tokens available. And we're going kind of fast here. So for anybody that is a little confused on what I'm saying, since this is just a recap, feel free to check out the first episode, or not really episode, but the first part of this workshop. Because I go in and I really explain more what all this means, and I go a lot slower because that was like an hour long just creating this code that we have right here. But again, just trying to go through quickly so we can get to the second part of this workshop to finish up this contract. And then the rest of the code here are all functions that we created to do things like getting the total supply. So remember, this variable is private. We can't read it on an explorer. So we have to have a way for users to get that value. And so we create what's called a getter function, which is a public function that gives you the value of a private variable. And this is just like a good design practice in general, is to um, have certain values in your contract private so that you control if it is possible for someone to view it through a function, because maybe you want to manipulate this value before you display it to a user. So you might store it internally in the contract in some way, but you want to display it to users in a different way. And that's why you see this design pattern often of having a private variable in a contract that is made public to people through a function. Because maybe I'd want to, um, I don't know, divide the number before displaying it, or I want to add something to it, whatever it might be. So we have those getter functions for all the values in our smart contract. And then we have the mint function, which all it does is it just changes the total supply. So as a parameter of the function, we say who we want to mint the tokens to, and then we say how many are we going to mint. And so then we just change the total supply to be what it was before plus the new amount that we're minting. And then we take that balance mapping. So we say the balance for this address that we're minting to is equal to what it was before plus the new amount. So we're increasing the balance of this person by the amount of tokens that we're minting, and we're adding onto the total supply, and that's all we're doing for minting. And then we can also view the balance of a single person by returning the balance of the address that we're looking at. So we give it the address, and then we map that to their balance, and then we return that as the value. So you can see right here that it is a function that returns an integer. So this unsigned integer is the balance of the address that we are querying for with that parameter right there. And then the last function that we created in the first part of this workshop is the transfer function. So we can actually take a token from one address, from our address, and send it to another person. So we say, okay, who do we want to send these tokens to, and how many do we want to send? And so first what we do is we determine what our balance is. So we look at, again, that balance mapping, and we say for our address, how many tokens do we have, that number right there. And then we have a require statement, because when you're transferring tokens, you are only allowed to transfer an amount that you have, or that is less than what you have. So we require our balance. The from means it is coming from us. We are requiring our balance to be greater than or equal to, that's what this means right here, greater than or equal to the amount that we are trying to send. And if that is not true, then the transaction will revert. A lot of you are familiar with transactions reverting on the blockchain. And then this message is what it gives you as the revert message. So this is just, we're kind of being a little silly here. Like the contract is giga gains, and then these require messages are kind of silly. It just says you're broke. Please get more giga gains tokens before you'd be able to transfer this amount. And then once we do that, all we do is we update the balances for both ourselves and the person we're sending the tokens to. So message.sender is a value in solidity that represents the address of the person that is calling this function. So in that case, that is us. We are transferring the tokens. We are calling this function, and thus we are the message sender. So you can think of the message sort of as like the information that you're giving this function. And so we are the sender of that. So we decrease, this minus equals means we are decreasing our balance by the amount that we're sending. And then the balance of the person we are sending it to is increased by what we are sending. So that's everything that we did in part one. So that was a quick like 8-minute recap right there to get everybody up to speed, and then just as a quick refresher for what we did. So at this point, we have a smart contract where we provide the initial values when we deploy it, and we set the name, the symbol, the total supply. We click deploy, so I can do that right here. I click transact to deploy it in Remix. And then now we have all these functions. We can get a balance of somebody, so I can copy my address, and I'm getting the balance of my address that I deployed it with, which is going to be equal to the total supply. Because you can see in the constructor, we are minting the total supply, that number of tokens, to the message sender, which remember is the person that ran the transaction. I deployed the contract, which means I'm the one who called this constructor, this function that runs when the contract is first deployed, and thus the tokens are minted to me. And so that's when I check the balance of my own address, I get the total supply back, that 10,000 value. And then we have all these getter functions. So if I click these, you get these values. I'm the owner. The contract name is Giga Gains. The symbol is Giga, and the total supply is 10,000, which again is that exact value for my balance. And then I can also transfer as well. So I could say I want to transfer to. I'll just like type a random thing right here, and then I want to send 1,000 of my tokens, and I would click transact. And obviously this fails because I just typed random stuff for the address. It's not a real address, but if that was a real address, then I would now have 9,000 tokens after, and then that other address would have 1,000. So that's all we have at this point. Pretty simple. The next thing that I want to add to really like start the new content for part two of this workshop is I want to add what's called approvals in the smart contract. Because one of the key things in any token smart contract is there needs to be the functionality there for people to spend other people's tokens. And you might wonder why you would actually need that. Like it seems like such a niche thing where you would need to be able to spend somebody else's tokens. But the best example I can give is why this is required is just go on an exchange. Like I'm on PancakeSwap right here. And look at what happens when I want to sell my tokens. Like in this case, I'm just using Omni as an example from the project Omniverse. And I'm trying to sell zero point 0.2 tokens. I just gave a random number. But look at this. When I go down to PancakeSwap or when I go down to the actual buttons to like perform this operation, as I'm sure a lot of you have seen before, there's two things I have to do. I have to click on this what's called Enable Omni before I can actually do the swap to sell my Omni tokens. The reason that this is required is because PancakeSwap, when you sell a token, it is actually transferring your token. So it needs the approval to spend your tokens before it can actually do the swap. So when I click on Enable Omni right here, my MetaMask pops up and it says, hey, you need to give permission to PancakeSwap to access your Omni. And you can see that what it's doing is it's approving PancakeSwap to sell your tokens or to transfer your tokens. And so that's like one of the main examples of why you need approvals in your smart contract is because that's how exchanges work or anything that needs to do something with your tokens because it needs to take your tokens in the same transaction that it gives you the other token that you're swapping it for. And so that's what we're going to code in right now. So the first thing that we're going to do is we're going to create another mapping in this smart contract. And so just like with the balances, we're going to start with this mapping keyword and we're going to map an address. And it gets a little complicated here, but I'll explain it once I'm done typing it. We're going to map an address to yet another mapping that maps an address to a number. and we're going to call that allowances, if I can type right, like that. So every person that operates on the smart contract, they're going to have an address, and we're going to map that to another mapping. So this address represents the token owner. Now this mapping represents what any other address can spend of their tokens. So if we were to, let's say, I'll give an example right here. We'll say we're going to map me, Cole, to another mapping where we have Zach 1000, and we'll say we'll have Chris. I'm just giving a couple of examples here from people on our team. 50. So this is kind of a representation of what this data could look like. So this is me. I'm the owner of these tokens. And now this second layer, the second mapping, Zach is allowed to spend 1,000 of my tokens. Chris is allowed to spend 50 of my tokens. So for every address, this mapping determines what any other person can spend of my tokens. So this is kind of a complicated variable on this blockchain, but there's a lot of information that needs to be stored there because any person needs to be able to have an allowance from any other address to spend their tokens, and it needs to specify how many tokens they can spend. So that's what this allowance mapping means, and it'll make more sense once we actually start coding the functions revolving around this approval system. So what I'll do now is I'll go down to the bottom of the contract and I'll make a new function. So we'll get started on really implementing this so that we could actually have this swapping functionality where like we could give PancakeSwap permission to sell our token or to transfer it for a swap. So the first thing that we want to do is make a function to approve one person to spend another person's tokens. It's as simple as that. So we'll say function and we'll call it approve. And the parameters here, we need to specify who the owner is of these tokens that we're going to give someone else approval to spend. And then, of course, we have the actual spender, so who is going to be given permission to transfer someone else's tokens. And then the last value here is the amount. How many tokens is spender going to be allowed to spend from owner? And we're going to make this an internal function, so it can't be called outside of from within this contract. Or actually, no, we'll make it public. There's kind of a reason to do both. I won't get into those details right now. A lot of times you'll make a function private and then have another function that's public that uses it, but that's a design pattern that we don't really need to get into right now. But anyway, this function is very simple because all we're going to do is we're going to update this allowances mapping for the owner with the spender. So we'll say the allowances of owner. So we are within this first layer of the mapping, we specified this value right here, the owner. And now we're within this mapping right here. So we're going to have another bracket right here since we're in the second layer of the mapping, and that'll just be the spender. So the allowances, what spender is allowed to spend from owner is going to be equal to the amount that we gave as a parameter to this approve function. And it's as simple as that. It's just one line of code in a very basic sense. And one thing I want to clarify here is that I'm simplifying things a little bit. If you were to look at like the official implementation of what's called an ERC20 token, so this is like the standard for a token smart contract. And if I go down to the approve function, um, I'll go to this one right here. You can see that it's a little more complicated than that. This is the line of code that I added right here, but there's a couple of other things that they add, but those aren't really required, and I can get into that if we have some time too. But in a really basic sense, this is all that needs to happen, is I've now changed the allowance of owner for spender to this amount right here. So now that we have the ability to set the allowance, which is what, when I click on this function, this button right here in PancakeSwap, I am calling that approve function that I made just now, where the spender is the PancakeSwap router address and the owner is me. So it takes my own address since my wallet's connected to this website, and it uses that as a parameter. And then the approve function, the amount for that is just the value right here. So it takes my address, it knows its own address, the PancakeSwap router, and then the amount that it approves is what I'm trying to sell. And that's how it gets those three values right there. So now I need a way to actually spend that allowance, because when I transfer someone else's tokens, in that function that transfers someone else's tokens, it also needs to spend the allowance, so they can't just repeatedly transfer the amount of tokens that they are approved one time. It's a one-time approval. It's not like I'm saying you can spend 1,000 of my tokens however many times you want. It's just one time you can spend 1,000 tokens, or two times you could spend 500. It just whatever adds up to 1,000. And so now we need to make a function called spend allowance, which is going to decrease an allowance based off of an amount that's passed in. So we have the owner and the spender again. And just like before, we have the amount that we're going to spend from the allowance. And so and we're going to make this internal because it's just going to be used within the smart contract, and we'll see where that'll be used shortly. This has exactly the same parameters as above. You can see when I highlight it, it kind of like highlights it up here as well, like showing you like it's exactly the same. And then all we're going to do here is we're gonna fetch the allowance that is currently set for the owner and the spender. So I'll say uint 256, an unsigned integer of size 256 bytes, and I'm going to call this value current allowance. And we're going to get the value from the allowances. So I'll say allowances, and then we'll do owner, and then we'll do spender. So this is exactly the same as what we have right here, because we're just getting the allowance for the owner of the spender. And then I'll go down. And so now we need to do a check here. We need to see if we can actually spend this much allowance from the owner. So we'll require the current allowance, this value that we got just now, we're going to require it to be greater than or equal to the amount that we are trying to spend. And so what this is saying, why this might fail, is if this amount right here is more than we're actually allowed to spend, then we can't spend that allowance. It's not allowed, because then they're spending more than the other person actually allowed them to. Like if I clicked on this button and I approved it, and then I click swap, and PancakeSwap tried to spend zero point 0.3 of my tokens when I only approved 0.2, well, then I would want that to fail. Otherwise, there's a way for them to just siphon more funds than I actually gave them permission to do. And so that's what this function checks to make sure it can't happen. So the error message here can be whatever. It says, I could say like, you can't spend this many tokens from the other person. Just something like that. It can literally be whatever. This is just a string that is given back to someone in a revert message if it fails, because current allowance is less than the amount. That's why it would fail. So that's my require statement. So now if I get past this line right here, that means that I am in fact allowed to spend at least the amount that I'm specifying here, if not more. And so now all I have to do at this point is I have to approve again. So I'm going to call the approve function with the owner and the spender. The value for the amount is going to be the current allowance minus what I'm currently spending. So the result of calling this function is I am decreasing the allowance by the amount that I'm going to spend. So if I approve PancakeSwap to spend 1,000 of my tokens and they spend 500, well, the current allowance would be 1,000, the amount would be 500. So now they'd be left with the permission to spend 500 more of my tokens. And if they did this again with 300 tokens, then after they'd be allowed to spend 200 more. And if they spend 200, then this spend allowance would be called one last time, bringing their approval to spend my tokens down to 0. And that's all this function has to do. So it checks to make sure it can actually spend that much, and then it changes the approval. And so now we have two functionalities here. We can actually set the approval, and we can spend the allowance. But it still doesn't do a lot for us here, because we need to actually have the functionality to transfer someone else's tokens. So that's what we're going to do here. We're going to make a function that's similar to transfer, except it's called transfer from. And this takes 3 arguments instead of 2. Because in this classic transfer function, we are assuming that the tokens are coming from ourselves. That's why we do this right here. We update the balance for ourselves to what it was before minus the amount. But in transfer from, we are not assuming the tokens are coming from ourselves like we are with transfer. Instead, we have a third parameter, which is the from address. Who are we taking the tokens from? Which address are the tokens coming from? And then the other two parameters are exactly the same as the transfer function. So I can literally just copy them over here. So everything's the same except we are no longer assuming that the tokens are coming from us because we're going to spend the tokens from someone else given we have the allowance to do so. So the flow is someone approves us to spend their tokens, like we approve PancakeSwap, for example, and then they call this transfer from function to actually take those tokens. So there's two steps that have to be there, which is why we have two buttons right here on PancakeSwap because we have to approve PancakeSwap to send our tokens, and then we actually click this button, this swap button, which would call the transfer from function with our address as the parameter and their address, the PancakeSwap router, as the to address, because the Omni tokens in this case go to them, and then the cake tokens go to us. So we'll make this a public function. We won't have it return anything, at least for now. And then all we need to do is we need to first get the address of the spender, which is the message sender. So the person who sent this message, they are not the person transferring their tokens necessarily like they are in the transfer, but instead they are the person spending. So we still care about this value like we do in the transfer function, but just under a different context because they're the ones spending the tokens now. And it's not necessarily coming from them. It could be, like, technically you could call transfer from where the from address is your own, and in that case, it would basically be the exact same as a transfer function, because that assumption would apply to this if the from address is your own. So we get the address of the spender right here, and then what we do is we call spend allowance, where the owner, nope, wrong function, the owner in spend allowance is the person the tokens are coming from, and the spender is the spender value that we got just right here, the person that's calling the function. And then the amount is the amount that we passed into the transfer from function. So it's as simple as that. We spend the allowance, and if what we're trying to transfer is greater than the allowance, this function would revert, and thus the transfer from would revert. So we can assume that if we make it past this function call right here, we can assume that we're good to go. We're good to transfer whatever many tokens we specify right here because when we spent the allowance, we didn't fail. So that's all I have to do. Now I just call the transfer function, or no, sorry, I don't call the transfer function. Now I can just update the balances. So I'll say the balances of the from address is minus equal the amount, and the balances of the to address is plus equal the amount. So I make sure I can spend the tokens, and then I actually do so. So I decrease whoever it's coming from by the amount, and then I increase whoever it's going to by the amount. And that's all I need to do for the transfer to work. So now we have the functionality that we need for this swap to take place in PancakeSwap. Like if we put this token on the blockchain, we could hook it into this decentralized exchange, and now it has everything it needs because it has the transfer function and it has a transfer from function with the allowances. So we're all good to go there. There's a couple more functions that I want to add, but I'm going to stop right here for any questions that you guys might have because I know I've covered a lot right here. I just kind of wanted to get the basics down for the approval system and the transfer from, and then I think now is a good time to stop for questions. So you guys can put anything in chat or just feel free to unmute. It would be even better too if any of you have any questions. I can check the crew chat right here. Pi asked, "How do I get those rebases?" You talking about rebase tokens? I assume you are. In that case, that's quite a complex topic versus what we're going over, just like the foundations of coding a token. But what I'm showing right now is definitely a necessity for getting to that point of actually coding a rebase token because you still need to have all of the basics right here. Like no matter what you're doing in a smart contract for a token, if you want to do rebasing, if you want to do transaction fees, if you want to do staking, if you want to do airdrops, whatever it is, you still need to have the approval system. You still need to have the ability to transfer. The total supply needs to be set. You've got to have the balances. You've got to have the owner, the minting. So yeah, that's like something that I wouldn't really go into right now. Maybe at some point I could do a workshop for making a rebase token specifically because that would actually go off of what I've already done here. But yeah, this is definitely out of scope for this workshop right here because rebase tokens are not super simple, especially because they deal with time. And working with time in smart contract is a very interesting and kind of advanced topic, if you will. But yeah, that's a good question. Yeah, any other questions? If not, I can move on to the next couple functions that I wanted to add. One of them is really basic. I wanted to add a getter function quick because you can see that I made the allowances private. So I want a function to be able to get the allowance from an owner and a spender. So I'll just code that in quick. It's gonna be pretty easy. No new topics here really. So I'll just say we have the owner and then we have the spender. So I want to get how much one person is allowed to spend from another person's tokens. So this is a public function. Anybody can call it on something like the Polygon Explorer or Ether Explorer. And this is a view. We're saying this is a view just like our other getter functions. This is a keyword saying nothing on the blockchain is actually changing. We are just getting information. And this returns to us a uint256. This is a number representing how much spender is allowed to spend of the owner's tokens. And so all we need to do right here is we need to return, and I can just copy this from one of our other proof functions right here. I'm returning the allowances that spender has over owner's tokens. That's all it is. So now if I deploy GigaGains again, so again, this is the first tab right here is where you see all the files in Remix. If I go down to the compile tab, I can click compile, which will tell me if I have any errors, and the check mark here is telling me I don't. And then the fourth tab right here is the deployment tab, so I'll say GigaGains. I'll kind of just get the same values I did before, and I'll click transact. So now I have the function just like we looked at in the recap from part one, but now I have all these extra functions. And so I can view the allowances of somebody now. So I'll take, for example, let's see, this is not real addresses. I don't actually have 100 Ethereum on all these different addresses. This is what Remix gives me on a test blockchain. So I'll copy this right here, and I'm going to say I'm going to approve this other address, and I'll go back to the address I had that I deployed this. I'm going to approve the second address to spend my tokens, and the amount I'll give is like, let's say 500. So I'll click transact. Now this address has the ability to spend 500 of my tokens. So it's as simple as that. So now what I can do, first of all, is I can check the allowance. So I'll do for the owner, my tokens is my address. And then the spender is that second address that I copied from that drop down earlier. And I'll click call. You can see that it returns 500 now. If I were to swap this, so now the owner is that second address and the spender is my address that I deployed this contract with, the value is 0 because I never did that approval. Well, let's change that. I could swap these values here. So I'll copy, paste, copy that other address, paste it here, transact. So now I did that. And so if I call this function again without changing any of the parameters that I have right here, the value goes back up to 500. So now what I could do is I could call a transfer from. I could transfer from this address to my own for 500 tokens and click this button. Now that second address doesn't actually have any tokens, so this would fail. You can see right here, I get that X right there saying, hey, this failed because you can't spend this many tokens from the other person. They don't have that many tokens to spend is the real reason. So what I could do really quickly if I wanted to is I could transfer tokens to them. I could say I want to give 500 tokens to that second address right there. So now if I do the transfer from again, because this address now has 500 tokens, and because I have the allowance to spend 500 of their tokens, this transaction will now succeed. And it looks like it actually failed again, which is very curious. I think I probably did something wrong in these function calls right here. I might have transferred to myself or something. I'm not sure exactly. Let's see why that might be the case. Current allowance, the owner of the spender, transfer from. Yeah, I'm not sure exactly why. I'm trying to go so fast with these function calls here to get to the next part of the workshop that I don't know if I gave the right values there. Because first of all, I'll check their balance. So this is the person I'm trying to spend. So I can get the balance of it. I just paste their address in right here, and they have this many tokens. Which, oh, right. Yeah, because that was my own address. So I gotta flip these two here. And copy there. So I flip these, and now I'll transact. And it failed still. The call function should be payable if you send the value, and your value should be less than your current balances. Yeah, so I called these functions wrong. I have it set up wrong somewhere in these transfers that I was doing to actually get the balances. Because let me try to check this person's balance. Oh yeah, they have 0. So I transferred 500 tokens to myself when I meant to send it to that other address, and that's why it was failing. So I'll actually send 500 tokens to the other person now. And now if I do the transfer from their address to mine, it'll work. So there we go. Now it worked. So I confused myself because I accidentally sent myself 500 tokens. And when I'm referring to myself, I'm talking about the address that I deploy the contract with instead of sending it to the other address. So that's why it was failing before. But now you can see I got the check mark and it's working because I was able to actually send the tokens to the right person and then call the transfer from. So I got the approval from the other address to spend 500 tokens. And then with this transfer from call, I actually sent 500 tokens from them back over to me. So sorry about that little mix up there. Just sent the tokens to myself on accident. But now we can move forward to the next part right here because we have the approval system all set up. So now with the last like 15 minutes we have here, I can just add a couple other things that are key functionalities within a smart contract. The first one being, there's one big thing that's missing right here in this contract that a lot of tokens have, and that is the ability to burn tokens. Because right now we have a way to mint, we can increase the supply of the total supply of the tokens in this contract, but we don't have a way to decrease it. And that's really crucial. Like here at Cardinal House, for example, the ability to burn tokens is really important because a portion of the revenue that we get from our services that we provide to other projects we burn to permanently increase the liquidity of the Cardinal token. And so we have to have a way to get rid of those tokens because we take the revenue from the services we offer, we buy the Cardinal tokens, and then we burn it. Which there's a couple ways you can do it. You can burn tokens by sending it to a dead address, for example. Or another way is you can just decrease the total supply and remove those tokens from a specific person. And so that's what I'm going to create right here. So right below the mint function, I'll create a function called burn. And just like when we're minting, we need the account that we are taking the tokens from, and then we need a number that represents the amount of tokens that we are going to take from someone. So we're going to subtract the balance of account by the amount, and then we're also going to decrease the total supply by the amount. So we're going to do exactly what we did in the minting function, except total supply is going to be equal to total supply minus amount. And the balance of account is going to be what it was before minus the amount. So it's literally just doing the exact opposite of the mint. But one thing that we might want to do is we might want to make sure that that the total supply isn't going below 0 because you can't even have a number less than 0 in solidity. So what we could do is we could require the total supply to be greater than or equal to the amount that we are trying to burn. You can't burn this many tokens. Like this could be the error that's given if you try to burn more than what's already left in the total supply. So that's just like a quick sanity check there to make sure that you're not calling this function mint burning more than what is already there. Minting, like the number can grow insanely large, and so we don't have to worry about having that check, but we can't have a number less than 0 in solidity, and we wouldn't want to have a negative total supply anyway, so it just makes sense to make sure that we can't actually do that. So that's great. We have these functions to mint and to burn, but there's a problem here. These functions are internal. There's not a way for me to call this on an explorer. or any other way that I might interact with a smart contract. The only way you can call mint and burn is from within the contract itself. Like we have an example right here in the constructor, we call the mint function because that is an operation that is internal to the smart contract. We enter the smart contract here, and then within this function, we're able to call anything we want, even if it's internal. But what if we want to mint more tokens outside of the smart contract after we've already deployed it? We need to have a public function that calls this mint function. So we'll call it function mint. So the internal one starts with an underscore. This is just common practice that you see, like even in the official implementation of the ERC20. That's like the name of the token standard. You can see we have the underscore approved for the internal function. But then if I go to the not internal one, the public one, you can see that it's just approved without an underscore. So it's kind of a common design pattern right there. So I'll go back to my remix right here and I'll say mint. And again, we're doing the account. And so we're going to have the exact same parameters. We have who we're minting it to and what the amount is, but this time we're making it a public function. So anybody can call it. However, we don't want anybody to be able to mint. We want to limit it so that only the owner of the contract, the person who deployed it, can mint the functions or can mint the tokens. And so I'm going to add a require statement here. I'm going to say that the message sender, the person who is calling this mint function, their address has to be equal to the address of the owner. So luckily enough, we already have the address of the owner stored in this value right here, which is one of the values that we set in the constructor when we deploy this function. And so we don't have to do anything extra to get the owner here. We can just check it right here. So the person calling mint has to be the owner. And if that's not the case, the revert message, we can say anything really, like I kind of mentioned for any require statement. But in this case, we could just say only the owner of this contract can mint Giga tokens. Simple as that. Now, once we get here past the require statement, we can assume that the person calling this mint function is the owner, because otherwise the transaction would have reverted with this require statement. So now it's as simple as saying mint, and then we pass the parameters that we just gave to this function. So we have the account and the amount, and then we also send the account and the amount to the mint function, the internal version. And that's all we have to do. So now we have a way to mint after the contract is deployed, and only the owner can do it. And then we can do the same thing with the burn function. So I'll say function burn, again, without the underscore in front of it, because this is the public version of the function. We have the account, and then we have the number representing the amount that we're going to burn, and I'm making this a public function. And just like with the public mint function, I need to require the message sender to be the owner because we don't want anybody to be able to just burn the Giga token. That'd be really bad, especially because you can burn the Giga token from any account. That would not be good. So we'll require it to be the owner again, the person calling this function. And then once you get past this point, again, that means that the person operating this function really is the owner. Otherwise, it wouldn't get to this line of code right here. And so we'll just burn with the account and the amount. So it's pretty much the same there because really minting is just the opposite of burning. So that's all we have to do. So now we have the ability to mint and burn with just the account or with just the owner. So that's pretty much it there. So now we have a pretty complete token contract, all the basics. We have the balances and the allowances. We have ways to get those values. We have ways to get all of these values, the metadata about the token. We can transfer tokens, spend other people's tokens, we can mint tokens, and we can burn tokens. And that's really the basics of all you would need to code a token that can work in the real world. And like I mentioned a couple times already, anything on top of that, any other utility that you need can just be built off of what we have right here. Because no matter what you're doing with the token, you need this functionality. The reason that we have standards like this right here, ERC20, is just basically like it defines a standard for what tokens need to do on the blockchain. There's also other standards, like we have ERC 721. This is a standard for non-fungible tokens, for NFTs. So there's a standard for everything on the blockchain. There's a certain way that other contracts expect a token to behave, like PancakeSwap, for example. If I don't have a transfer function in my token, I cannot have it on PancakeSwap because if I try to buy a token that doesn't have a transfer function, it's not going to know how to operate my token. Or if I try to sell a token that doesn't have a transfer from function or any of the approval system set up, it's not going to know how to work. It's just going to fail straight up. So you need that there for you to list on a decentralized exchange, for you to list on a centralized exchange, for you to integrate with any other contract that might be there. So it's really really important to have all of the standard implementation of a token contract in your token contract, which is kind of nice why we have these things like um, this right here, which defines exactly everything that you need within a smart contract for a token. And so instead of having to memorize everything that I did right here, instead what you can do is you can just go to this contract and you can say, okay, here's everything that I need for a token. And then anything more that I might want, I can add on top of it. Like if I want to add rebasing, for example, I can work off of this because this is everything I need. And then any other utility like rebasing or airdrops, whatever, can be built on top of it. So I'm going to pause another time here for any other questions that we might have. And then I can kind of go into a couple last minute things or last bit things to wrap things up. Any questions at this point? All right. I think I will take that as we are good to go then. Yeah, so one other thing that I wanted to show, which simplifies things quite a bit. I'm actually going to go to the code that I have for the smart contract for Cardinal House, the Cardinal token. I'm gonna show something really nifty here. So I was showing earlier this Open Zeppelin page. So Open Zeppelin is a really cool project that has all of these standards in a GitHub repository. So if you want to know what it takes to make a token contract, you go to this right here. If you want to know what it takes to make an NFT contract, you can go to the ERC 721. And so this is exactly what I was showing for the token, but now this is for an NFT. So this is implementation of the non-fungible token standard. So this is everything that you would need in an NFT contract to, let's say, list on OpenSea, for example. So just like there's requirements for having a token on PancakeSwap, like you have to have the allowances, you have to have the transfer, you have to have the transfer from. There's requirements for having NFT contracts on OpenSea, for example, like you have to have a lot of the same things, really. Like you have to have a transfer and transfer from function for NFTs as well. You also have to have the token URI, which is basically just the metadata about the token or about the NFT, like what's the name, what's the description, where can I go fetch the image for the NFT, that kind of thing. That's all stored in here. So you have that standard as well. Now, what's really nice is if you don't want to code everything from scratch, like I showed right here, you can actually build a token contract off of everything that we have right here. So if I go to the Cardinal token contract right here, you can see I did what's called an import. I imported the ERC20.sol file from OpenZeppelin. So I took this code, and this is what a lot of smart contracts do, so they don't have to make things from scratch. I took all this code and I imported it into my code. So effectively, what this does is it takes all of the code that I just showed you on that page on GitHub and it puts it right here, right where this import statement is. So now I have all of that ERC20 code. So now what I can do for my Cardinal token is instead of having to define everything from scratch, the balances, the name, the symbol, total supply, the allowances, all that, I can get it automatically by saying Cardinal token is ERC20. And that's what's called inheritance. My Cardinal token is inheriting all of the functionality from the ERC20 contract from OpenZeppelin. So everything that you see right here now becomes a part of my Cardinal token contract. So I don't have to code all this from scratch. The reason why I did all this from scratch for you guys is because it's important to understand the foundations of what makes a token contract before you just import this because you need to know what you're importing and what you can leverage and how to leverage it. Because when I inherit, I now have everything from that. I have the transfer, I have the approval, I have the total supply, I have the minting, I have the burning, I have all of that, but I still need to know how to use it for the functionality that I'm going to build on top of the ERC20 standard, because the ERC20 standard gives me the foundations. But when I want to implement fees, or I want to implement blacklisting, those kind of things, I need to know how to actually use the functions that I have now from ERC20, from that base token contract, to implement what I need for the Cardinal token. And so an example of that right here is I create my own transfer function. You can see that, and this is getting a little bit more advanced. So this is just kind of giving you like a little glimpse into what you can do to build on top of it. I won't go into like super big details here, but you can see here that I have the override keyword when I'm declaring this transfer function. What that's saying is, hey, I have this transfer function in the contract that I'm inheriting from. And so really, I don't have to define my own transfer. But what if I want to override the transfer function to add my own functionality? And that's exactly what I'm doing here. This is how I implement transaction fees and blacklisting and all of the other things that I'm doing in the Cardinal token transfer function. Because I'm overriding what I get when I am inheriting the token contract from Open Zeppelin. So I do all this stuff like I make sure they're not blacklisted. Um, I make sure investors aren't getting more than 5% of the total supply when purchasing from a decentralized exchange. If someone is excluded from fees, then I just do the transfer. So basically, at that point, it'd be exactly the functionality that we have right here, where I just call that base internal transfer function. But then if they're not excluded from fees, then I calculate the fees, I send the fees to the respective wallets, and then I finally perform the transfer. So all that extra complexity is put into this transfer function that I override from this transfer function right here. And again, that's getting a little bit of the deep end there with how to add utility on top of a base token contract. But I just wanted to, again, give a glimpse onto a little bit of what that looks like, where you can take the basics, like everything you have to have, you can use that to inherit from for your contract, and then add whatever else you might need for rebasing, for example, if you wanted to do that. But it all comes down to you still need to really understand at a fundamental level what all of this stuff is doing in a foundational token smart contract. Because if you don't understand the fact that there's a transfer from for the approval system and a transfer function for regular transfers, it can burn you because you have to be aware of both. If you, for example, if you set up a transaction fee for just the transfer function, well, guess what? That transaction fee is not going to work when you're selling tokens because the transfer from function is the function that's actually used when you're selling tokens, not the transfer function. So if you import from the base token contract and don't know that, and you just set up a transaction fee on the transfer function, then your transaction fee is not going to be applied half the time because you also need to set it up on the transfer from function since both of those are used in different use cases. This transfer from is used in the approval system when you're spending someone else's tokens, and the transfer function is used when you are transferring your own tokens. Remember, it assumes that you are the person the tokens are coming from. And so, yeah, there's things like that where it's just really important to understand exactly what a smart contract has to do, and then everything on top of that, you can understand going from there, and then you have the foundation. So yeah, I think that's where I'll leave it there. Because at this point, if you've been following along or just watching, you know exactly how to make a token contract, what goes into it, and a little bit of an idea on how to build on top of that for extra utility to like really make your token unique for whatever project you have going, whatever kind of utility you need. So I'd like to end this with if you have any questions about any of this, or if you want to dive more into actually adding more onto your token, I'd love to chat. I always love to help anybody out with this kind of stuff because it's what I'm passionate about and I like helping people. So yeah, always happy to help and maybe in the future I'll also host some more workshops getting into specific utility and exactly how to add onto this contract to get those kind of things going. Or maybe I could do an NFT workshop so I could teach how to make this but with NFTs instead of tokens. There's a lot of different things I can go over. I'd just be curious what people are interested in. So kind of figure that out over time and get some more workshops hosted over the next few months here. So yeah, I think I'll leave it for that. Any questions before we end it here, or any feedback, whatever you guys got?
When Giga Gains launch?
So I'll probably avoid launching Giga Gains because that would be kind of odd, and I would not know what to do if people started buying a token that they should not buy. That actually happened once where there was this YouTuber that did something similar to what I was doing here, where he's just teaching how to code a token contract, and then just for the heck of it, he decided to actually deploy it and put it on the live blockchain, like on the main net for Binance or whatever, and a ton of people started buying his token, even though he put in like $100 of liquidity just for like a demonstration purpose. By the way, which is another thing I can teach all y'all how to do is actually deploy it and add liquidity to it. But anyway, it's a topic for another day. But yeah, he did that, and people actually started buying, and he made like $3 million off of it. But he made another YouTube video like a couple months later, like, "Hey, I've made $3 million off of this token that was just meant for educational purposes." And he's like, "I think it'd be pretty unethical if I actually took those profits." So he took all the tokens that were worth $3 million and he just burnt it because and good for him. He should that was the right thing to do because it was just a token meant for educational purposes. It had no real utility. Um, it'd be a huge security violation, SEC violation to like really take profits from that if it's just for educational purposes. So yeah, no Giga Gains launched. I'm sorry.
Dang. But no,
Pi
this
project has.
was. Sorry, go ahead.
I was just gonna say, Pi said Pi project has been delayed until Cold teaches rebasing. All FUD to be redirected. Well, maybe I should get on that. Maybe that could be the next workshop then, is how to do rebasing. But I'd have to see how complicated that really be, because that might be quite a long workshop or something like that. But hey, it could be cool. I could look into that. But yeah, what
Yeah,
were you gonna say, Zach? I think you're gonna wrap it up.
yeah. I was just gonna say I appreciate you taking the time to teach us how to make our own token. Um, it's definitely there's a lot that goes into it, and there's a lot that I took from it, and a lot that I did not understand at all, just because I'm not a developer. But yeah,
Yes. It's all good. And yeah, I know like for those of you who aren't developers, it's definitely gonna take a bit to grasp everything there. But I think any bit that you can take away is good, because any amount of spot checking that you can do in a contract before you invest is good. Just to quickly see, like, is there anything that like really jumps out as not making sense when you're like I said at the start of this, if you're looking into a new project and you're taking that risk of being one of the very first investors in something that could be big, but right now is really small. No one's really audited it yet. There could be a big reason why, or like no one's really had the chance to tell anyone else if there's red flags. Like maybe you're that first person. It's good to have at least some skill to look into that a little bit. So yeah, hope this is helpful, everybody, and thanks for joining. I appreciate this, and I love doing stuff like this. So more in the future to come.
yeah. Take care,
Thanks.
everybody. Have a great rest of your weekend.
Yeah, thanks.